Hello, welcome. Today we will discuss cognitive theories for instructional design. Let's begin with cognitive load theory. According to Pass and Sweller, cognitive load theory is the processing of acquired knowledge. The cognitive architecture is the way we process information. We process information first in working memory and then storing information in long-term memory. These bits of stored information are cognitive structures called schemas. According to Sweller, schemas make up our knowledge base. They allow us to process multiple bits of information as single elements. So let's look at an example. For example, we have bits of schema here, ideas and concepts of feathers and talons and wings and beaks. But altogether, there's actual object of a bird, so that all that information is also stored in our knowledge of a bird. The difference between an expert and a novice is that the novice hasn't acquired the schemas of an expert. That takes time. So the novice has random bits of information, just taking it in, trying to make sense of it. An expert has that information and over time has organized and structured the different elements and made relationships with other schema. According to Pass and Sweller, working memory's capacity is very limited. When too much information is presented at once, it becomes overwhelming and much of that information is lost. Cognitive load theory helps you design training that reduces the demands on learners' working memory so they can learn more effectively. The cognitive theory of multimedia learning, according to Mayer, helps people by going through two different senses. We want to better understand things and we can learn better through both words and pictures. The cognitive theory of multimedia learning is based on three assumptions. The first is the dual channel assumption, that there are two separate channels. We have the auditory and verbal as one, and we have the visual and pictorial as another, and they process information separately. There's the limited capacity assumption, which is that each of these channels is limited in capacity, how much information can be processed at one time. And the active processing assumption is the third one, and this is that people must be actively engaged with their cognitive processing to make sense of any information. Mayer identified for learners to succeed that they must monitor their cognitive processes, that there are 5 different processes. In this diagram, we depict them. They need to select the relevant words. We need to select the relevant images. After doing so, you can organize those images, you can organize the words. And then lastly, we want to integrate all of our word-based and picture-based representations. And then this is, of course, the most critical step. Mayer emphasized the importance of the learner making connections with prior knowledge. Cognitive demand is great when making sense of it all and forming understanding. So let's apply these theories to design. According to Mayer and Figueroa, cognitive capacity is the total amount of cognitive processing the learner's working memory can handle at any one time. Extraneous overload occurs when the learner's cognitive capacity is exceeded. Extraneous cognitive load is caused by poor instructional design. It can be too much extraneous information, it can be poor instructional design layout, or it can be poor implementation of design. So we're going to take a look today to help us design. We're going to look at some principles and techniques that will help. Basically, we're going to look at spatial contiguity, coherence, signaling, as well as refutation text. So let's begin with spatial contiguity. What we want to keep in mind here is that the bullet point and the illustration should be on the same slide. The information should be close. We want to reduce the learner's need to scan back and forth and to find the information between words and pictures. When the material is complex or multi-stepped, Mayer and Figueroa says that this is most critical. So let's look at an example. Here we have an illustration of an apple pie, and next to it is the explanation and the detailed paragraph. They're close to each other. The learner doesn't have to turn a page to go back and look at the picture. They don't have to go ahead to a screen to remember what the text said about it. It's all close together. So why does spatial contiguity work? Well, this principle helps learners find relevant information. It focuses their attention and direction. Extraneous overload can be caused by poor instructional design layout, but this can be avoided using spatial contiguity. According to cognitive theory of multimedia learning, we want to help learners use their limited cognitive capacity for processing what's essential, rather than wasting it on extraneous items. So here's another example. See this formula? It's right here, and next to it, all of the variables are spelled out. The learner doesn't have to go back and forth. It's very clear what they're to do. Our next principle is coherence. This is where we want to eliminate extraneous material. Many of us are guilty of this when we're teaching. We often go off on tangents, or we want to tell cool facts. We want to stick to the essentials according to Mayer and Fiorella. Let's look at an example. Here we have this paragraph with information about guitars. And at the bottom here, there's some really neat information about Jimi Hendrix. And there's a great picture about Jimi. But they're not really relevant to the basic information we're trying to convey. So let's go ahead and remove those last couple of sentences and remove the picture as well. Why does coherence work? Well, less is more. According to Mayer and Fiorella, learners benefit when they can focus on essential material rather than processing both essential and extraneous information. The cognitive theory of multimedia learning states that you don't want to overload the limited processing in working memory. We want to reduce extraneous overload. We don't want it to be caused by overly detailed material or by poor instructional design, and we can avoid that by using coherence. So let's look at that same example, but now look, we have the relevant sentences as well as we have the guitars that are most common today with the pictures of them to clearly illustrate it as well as a label identifying what they are. We're moving on to the signaling principle. According to Van Gogh, this is when we want to highlight organization of material or bring attention to relevant elements in the material or highlight relationships between elements. Without proper design, unimportant features may grab the learner's attention and distract them. So let's take a look at this example. We have a football play, and then the little blurb to the right talks about a quarterback. But if you've never seen a football play before and you don't understand it, you don't know who the quarterback is. So with a little signaling, we can go ahead and draw attention to the quarterback and bring the information over to relate it and make it clear to the learner what is being referenced. And why does signaling work? Well, extraneous overload can be avoided using signaling because we're helping the learners to use their limited working memory capacity. We're helping the learners to select, to organize, to integrate their information that's presented in the materials, where the cues are emphasizing the relationship between elements in the text and the pictures. According to Mayer and Fiorella, the cognitive theory of multimedia learning states that learners can focus more on the processing of that essential material and working memory and less on the extraneous material, or less on trying to sort out what's important and what is not. Here's another example. This formula is actually not too bad. We have the formula, we have the variables right there. However, let's make it better. Let's bring a little signaling and let's cue those variables exactly right next to where they're defined in the formula. So now it's very clear to the learner what is being referenced. Now let's look at refutation text. This is a proven method to help facilitate conceptual change. According to Tippett, the text structures must contain two key parts. The first is that the commonly held misconception is stated clearly. And second, the disproof or refutation of that misconception is stated, supported by an explanation or by scientific explanation. There has been over 20 years of research that demonstrates that conceptual change can result from reading refutation text. So let's take a look at an example. In this example right here, Many people believe that negotiations are always competitive and combative. But, however, this is not true. So we have the first part. We've clearly stated the misconception. And then we move into explaining why it's not true. Why it's not true in every case. Refutation text may be seen as an expert source when it's well written. The text must present information in a credible, understandable, and useful way. And reading refutation text passages can produce sustained conceptual change. So in summary today, we've looked at two cognitive theories, the cognitive load theory and cognitive theory of multimedia learning. We want to apply instructional design principles and techniques to reduce extraneous cognitive load. In particular, we looked at spatial contiguity, where related words and pictures are located near one another, coherence, removing extraneous details, sticking to the details, signaling, where we cue and direct the learner's attention by the signals. We also applied refutation text, which helps to result in conceptual change. Instructional designers must consider the limitations of working memory and how human cognition works. The goal is to help learners understand by designing instruction to leverage how the human mind works. Thank you for joining me today.